Hi, I'm here with a new video series of robotics. So in this video series, we are going to enter into the world of robots and robotics. As this video series will start from basic and go till advanced level projects. I hope you all will enjoy and learn a lot new things from this video series. Before starting, make sure you subscribe the channel and hit the bell icon as I bring such an interesting video every week. So let's get started. Beginning with the basic definition of robot. That is, a robot is a machine programmable by a computer and capable of carrying out complex series of tasks automatically. The robot can do a specific task if it is programmed according to that. In the field of robotics, the term programming is called as teaching. The teacher uses teach pendant to teach a robot, and once the robot is programmed for a task, then it can carry the same task in a loop according to the control signal from the master PLC. One thing I would like to tell you is that robot is always a slave to its master controller. So moving on further, as we know that robot consists of motors, some electronics and the software that control all the components. So robotic is a combination of all these fields, that is mechanical engineering, electronics and electrical engineering and computer engineering. It is an interdisciplinary approach. Now let's take a look and know about the basic components a robot consists of. There are 6 types of components. The first is the body, the second the actuator, the third is the controller, then the end effector, certain sensors, and the most important is the software. The actuators are the torque providing components of a robot. It can be servo motor, stepper motor, pneumatic piston, hydraulic pistons, etc. The controllers are the electronic parts. They are used to generate certain control signal for the actuator for moving a robotic arm. As there is always a need of a feedback mechanism needed for a robot, and this feedback is given by the sensors. There are various kinds of sensors used in robots, and the task of controlling all these components is done by the software. This is all about the basic components of a robot. Next, let us see some of the terminologies used in robot. In robotics, a manipulator is a device used to manipulate material without direct physical contact by the operator. Here in the animation, you can see how the two manipulators are continuously doing the task in a loop format. The second is the reference frame. As the robot works in the 3D environment, there is a need to assign a particular reference frame at each point, so to know the position of the end effector with respect to the base frame. So here we have 2 types of reference frame. The first is the joint reference frame and the second is the world reference frame. There are certain rules to be followed in order to assign this coordinate system at each joint, and on the basis of this reference frame, further mathematical calculations are carried out in order to know the forward kinematics equation, the inverse kinematic equation, the robot motion control, robot dynamics, and many more things. So in coming lectures, in the coming series of videos, we are going to see all about these terms, but as this is a basic introduction, I am just giving you an overview of these concepts. So then coming next, the term, the degrees of freedom. It is the minimum number of independent variables needed to represent a robot in a 3D space. For example, for a point to be represented in a 3D space, we need 3 variables, that is x, y and z. That is what the degrees of freedom is. Now let's see different types of robot joints. So there are 5 different types of robot joints. The first is the linear joint. It helps in linear motion of robotic arm. In this animation, you can clearly see the movement of the robot arm. Then comes the rotational joint. This type will allow the joint to move in a rotary motion along the axis which is vertical to the arm axis. It is used when the robotic arm needs to be moved in a rotational motion. Then comes the twisting joint. So the name itself gives you idea how the joint will be. This joint makes twisting motion among the output and input link. Then we have the orthogonal joint. Here the input link is at angle of 90 degree to the output link. And at the last and most important is the revolute joint. This is the most used joint in a serial manipulator. Here the output link axis is perpendicular to the rotational axis and the input link is parallel to the rotational axis. The animation will make you clear what it actually is. So as there are various kinds of joint, depending on that there are various configuration of robot. the Cartesian coordinate robot, which workspace is cuboid like a shape, and mostly here the sliding joints are used. You can see in the animation how the robot is picking an object and placing into on the other pallet, and you can imagine the workspace of this Cartesian coordinate system. It is a cube like a shape. Then comes the cylindrical configuration robot, whose workspace is a cylinder. Here you can see in the animation the robot is manipulating its arm in a cylindrical like shape. And the third comes the spherical configuration robot. Here the robot's workspace is a sphere. It can manipulate an object, work in a spherical environment. And at the last, it is the articulated configuration. It has its own custom workspace according to the limits provided to each link in a serial manipulator. The robot can go till the limit, so the workspace is custom in this type of articulated robots. The animation here will make everything clear to you. Moving on the next term, that is the end effector. It is the end part of the robot that performs the important task of gripping or any other task according to the attachment. And as there are various types of attachment, we can attach at the end of robot. For example, a gripper can pick an object and place it on another, or whatever the operation you want to perform, you can perform it. Mostly in the automobile sector, the robots are used for welding purpose. So the end effector here, at the end effector here, the attachment is the welding torch. So this was all about the robots and robotics. Further, there are other mathematical terminologies like robot kinematics. In there are forward and inverse kinematics. Then comes the robot dynamics, then robot motion control, and many more. So it will be the subject for other video. Hope you like the video and my explanation. Please don't forget to give your feedback in the comment section, and also you can ask any doubts related to this video down in the comment section.